Hello class, we're going to look at Module 5, Chapter 5. We're going to talk about the ANOVA and the Kruskal-Wallis test. We're going to talk about post-hoc testing, effect size, the normal curve, and the standard deviation. Here are your learning objectives. You can look at those in the lesson plan. And I'm speeding through this because there's a lot of slides and I don't have enough time. Okay, we're going to use the ANOVA or the Kruskal-Wallis test, depending, and we'll talk about depending on what. What it does, it's a t-test, except that it's the kind of t-test that runs more than two groups. It really shouldn't be called a t-test. It's a t-test on steroids, but it'll run, you can examine more than two groups at a time. It's similar to the t-test. For instance, you examine these three groups, where in a t-test you would only be examining two groups. Let's do an example. Participants are recruited to determine the best method for reducing the pulse rate in those diagnosed with acute stress disorder. And here you have Group 1, the control group, the PET therapy group 2. So we're going to compare all these in the meditation group. And that just shows you an outline of the three comparisons. Analysis of variance. That's what we're using. Well, ANOVA and ANOVA is an analysis of variance. Hypothesis, there is no significant difference in the pulse rate. There is a difference in the pulse rate, your motivated hypothesis. So we're going to test those through the ANOVA. Before we can run it, just like the t-test, we have to test for normality, an N quota, and homogeneity of variance. Normality assumed in this one, if that's what it looks like. The ANOVA table was produced, so I know we skipped a lot of stuff in here, but the videos will show you how to do that. I just want to show you what the results are going to look like. We run the test, and this is the first thing that pops up in SPSS, the ANOVA screen. And it gives you the sum of the squares. That has to do with standard deviation, doesn't it? Sum of the squares. Degrees of freedom is 2 because you're doing 3 groups. And the F-score and the significance. This is really all you're interested in. One in red, 0.018. 0.018 means we reject the hypothesis, and the result is there is a significant difference in the pulse rates across the groups. Yeah, there's a difference, all right, but we're comparing 3 groups. Where's the difference? Is it between group 1 and 2, group 1 and 3, or group 2 and 3? We've got to know that. Or is it between all groups? So what we've got to do is figure out a way to test only 2 groups at a time and find out what those are. Well, those are called post-hoc tests, tests that are performed after the original test. And I think of it like the overtime in a hockey game. They're like t-tests, but they're going to be called something else. The names are either going to be a Tukey test or a SIDAC test, and we're going to perform post-hoc test. So here's the post-hoc test, and it's done via Tukey. And the reason we use the Tukey is because each group was made up of 30. They were equal groups. Now, look, it said the control group and the PET therapy group. Hey, that was significant comparison. There's a difference in those two, and it's significant. Now, if we look at control in the meditation group, we got 0.058. Well, that doesn't make it. That's close, but close is only good in horseshoes and hand grenades. Now, let's look at the third one. PET therapy and meditation. Hey, they're not even different. They're probably the same thing. Here's the results indicating that only the control and PET therapy group was significant with the asterisk. We're going to reject the null hypothesis, and we're going to accept the motivated hypothesis. There is a difference in pulse rate across the groups. We're going to write an abstract. And you can write this abstract in 2 ways. You can write it the way Knapp suggests you write it. And he has a format. Or I like to use the one that is in How to Use SPSS by Cronk. You can use the first half of Knapp and then write up. You can just go into Cronk's and look at how to write up an ANOVA. And you'll see this right here. Just see the whole thing, just like it is. So take your choice. I like this one best, but I'll count either one of them correct. ANOVA, unique pairs formula. Well, what does that mean? Well, if you have 2 groups, which like a t-test or one-way ANOVA, you only have one comparison to do. In in 3 groups, remember you got to compare 1 to 2, 2 to 3, and 1 to 3. Look what happens with 4 groups. You got to make 6 comparisons. What if you had to make 10 comparisons? Let's look and see. Don't worry about this formula. I would never ask you to use that. If you had 10 groups and you were doing an ANOVA and it came out significant, they would have to show you, they'd have to show you 45 post hoc tests, and they would look like this. Whoop, where'd they go? I gotta find those things. Well, I'm sorry for taking up your time there. Let's just talk about the Kruskal-Wallis test. Here we're using Mighty Mouse. The Kruskal-Wallis test is going to save the day for us. Well, it will, because when you have non-normality, you're going to have to use the Kruskal-Wallis test. And how you run it is in SPS, you're going to click Analyze, which we always do. Then you're going to go to Non-Parametric Test, because the word non-parametric means non-normal. That's all it means. Legacy dialogues, K independent groups, and then you're going to perform the test. And again, the videos are going to show you how to do this. And you're going to get a result. And look at, this is the same data for the 90 people that were in dog therapy, meditation, and control group. Is 0.03. So we had tables a lot smaller, isn't it? So with the Kruskal-Wallis test, assuming that the group was non-normal, we got this value. That means we have to do post hoc testing. Well, the unfortunate thing is Kruskal-Wallis doesn't do that for you like ANOVA does. You have to go back and run the post hoc test, and you actually just rerun the Kruskal-Wallis test comparing 2 groups at a time. You have to do every one of those. And here's what it'll look like when you get done. It'll be the same table. And it's a little bit like a t-test because you're comparing 2 groups. But again, it's been hijacked a little bit with what we call Bonferroni that makes a correction so you can do this. But anyway, it turns out that group 1 and 2, that's control in the dog therapy group or pet therapy. I said dogs, could be a cat, was significant. And here the meditation shows to be significant. But again, the meditation and the pet therapy don't show to be any different. Effect size, you're going to do some more effect size. When you get to ANOVAs, more than 2 groups, you can't calculate the effect size the same way. We have 2 choices to do this. You can find it, the effect size in SPSS. You just go look at it, and you have to do the univariate analysis, and we have a video showing you how to do this, and you'll find the effect size for the groups. Or you can go to this website, and it's in Psychometrica, and you can go there and it'll show you how to do that. I've got to hurry up. I'm about to run out of time here. Let's see. You're going to watch some videos, and the first ones you're going to watch are going to be on effect size. It's going to show you how to do an ANOVA, and then this is a publication about effect size, and here is a video about how to find the effect size. So ANOVA, run the ANOVA with post hoc tests. It'll show you how to do that, and effect size. Then if you want to know how to do effect size, you can click on this, and you can go to a website, and you want to keep this in mind, that will calculate the effect size for any comparisons that we make in this course via any statistic that we use in this course. So it's a place where you can go, put in the right data, and it will calculate it no matter what test you're using. Pretty handy place, I think. Part 2, you're just going to do the homework problems, 5.2a, 5.4a, and 5.10b. And you've got a video that's going to show you exactly how to do this one. It's similar to the video on 5.9b. So you'll have videos that'll show you how to do this. And then you're going to complete a worksheet on standard deviation. And here's what you should do first. You should read. You're going to open up a sheet. That's the video, but there'll be a file in the homework, and Up here it is, hand calculated standard deviation. Open that up first and then watch the video. Then you'll know what you're looking for. So, again, you've got these 3 videos to watch, and it'll show you that you're doing this one because the ends are equal, so you'll do the Tukey post hoc test. And the other test, when the ends aren't equal, is called the SIDAC. And this is going to talk about normality and that sort of thing. Kruskal-Wallis, you're going to see a video on that and how you run it in SPSS. And then it's going to show you exactly how to do problem 9, which is going to show you exactly how to do problem 10. And then you're going to do the worksheet on standard deviation. And if I didn't tell you, you need to save that standard deviation file to PDF. So here's all your assignment, telling you what to do. And this is your to-do list, and you have one of those. So good luck.